Good morning, all. Today, we learn about full wave bridge rectifier. In the last class, we have studied about full wave rectifier, and before that, we have learned about half wave rectifier, right? Now, in today's session, we will learn about a full wave bridge rectifier. Now, see the circuit given here. See the full wave bridge rectifier, you have got four diodes, that is diode D1, D2, D3 and D4, and they are connected in the form of a bridge, and that's why the name bridge rectifier or full wave bridge rectifier. Now here there is no center tapping for the transformer, that is the need for a center tapped power transformer is eliminated. Now the AC supply, that is the input AC that has to be converted to DC, is applied between the primary of the transformer, and then between the other two ends of the bridge you are connecting a load resistance RL here. Okay, now this is the circuit diagram. Now let's see the input waveform. This is a simple input waveform, a sine wave, and here you can note the output, it is continuous. Now let us see how this output is obtained. For that we have to go through this operation or working, so I will brief that, then you can go through this paragraph. Okay, so during the working is that during positive half cycle, what happens is that the diode D1 and D3 will be forward biased, that is they will conduct, whereas diode D2 and D4 will be reverse biased, that is I will not conduct. Since the diode D1 and D3 conduct, definitely you will get a output waveform, that is due to or current flow in the output due to the diode D1 and D3. Now what happens when negative half cycle comes? When negative half cycle comes, D1 and D3 will be reverse biased, that is they will not conduct, whereas diodes D2 and D4 will be forward biased and they will conduct. So definitely there will be a current flow in the output, that is in the output you can have a current flow, that is there will be an output waveform due to diode D2 and D4. Now again when positive half cycle comes, what happens? Just the reverse occurs, that is current flow will be due to D1 and D3, that is at that time only D1 and D3 will be forward biased. Now when negative half cycle comes, again you will get an output here due to diode D2 and D4. Now this process continues and you will get a continuous output DC. Okay, that's all about the working. And now here what is PIV? PIV means I have already told it is a maximum reverse voltage that can be applied to the diode without damaging the junction. Here it is VM. VM is nothing but maximum secondary voltage of the transformer, VM. Okay, now these are some of the advantages, means that there is no need for a center tap transformer. Now the output is twice when compared to that of the center tap circuit. The PIV is only one half of that when compared with that of a center type circuit. Now the disadvantage is that here we are making use of four diodes, and another thing is that during each half cycle, that is either during positive half cycle or negative half cycle of input AC, the conducting diodes are in series. So there will be a voltage drop in the internal resistance, and this will be very much high, that is it will be twice as great as in the case of a center tap circuit. Next is efficiency. Here efficiency, if you are asked to derive the expression for efficiency of a full wave bridge rectifier, you can derive the expression for the efficiency of a full wave rectifier, which I have already derived in the last class, so I am not explaining it more. Okay, so the efficiency is actually eta equal to DC power output by AC power input, that is PDC by PAC. PDC is equal to I square DC RL. IDC's expression is 2Im by pi, which is already derived in the last class, so that's square RL. Next is PAC is equal to I square RMS into twice RF plus RL. Expression for IRMS is Im by root 2, which is already derived in the last class. Please go through it. So that's square into twice RF plus RL. Now you can derive the expressions for IDC and IRMS or PDC and PAC similar to that of the full wave rectifier, which I have already derived in the last class. So please go through it. The only difference is that in place of RF, that is forward resistance of the diode, that is RF, we write twice or 2 RF. Why? Because two diodes are in series at a time here. Okay, now the efficiency eta will be 0.81 into RL by twice RF plus RL. So in the earlier case there was only RF, but here it is twice RF. The reason is that here we are using two diodes in series at a time. Now if RF is very much small compared to RL, what is will be the maximum efficiency? It will be 0.81 and ripple factor gamma will be 0.48. So the revision of part you can go to the last class. Okay, now Next is about a BJT, that is bipolar junction transistor or simply transistor. We know that it is a device whose output current is controlled by input current, and here it is called bipolar. Why? Because the current conduction is due to electrons or holes. Now here we learn about two type of transistors. One is NPN and the other is PNP. N actually stands for N-type semiconductor and P stands for P-type semiconductor. Okay, now see the circuit. This is for that of an NPN transistor, that is a thin P layer is sandwiched between two N layers. Okay, this is the emitter, base, collector. This is a circuit symbol. Let us see in the emitter circuit, the arrow is pointing outwards. Here, this one. You can see here arrow is pointing outwards. Now, whereas in the case of a PNP transistor, that is a thin N layer is sandwiched between two P layers. And here in the emitter circuit, the arrow is pointing inwards. This is the emitter, base, collector. And so in an NPN transistor, arrow is pointing outwards, whereas in a PNP transistor, arrow is pointing inwards. So just study the definition and the difference in the symbols. Okay. Now we will see what is emitter, base, collector and all. Now emitter is nothing but it is an outer part which is very thick, which is very heavily doped. So emitter is an outer part which is heavily doped and its function is to emit majority carriers. Now about collector, collector means it is very thick and doping level is intermediate and its function is to collect majority carriers. Whereas base is a thin and lightly doped region which provides proper interaction between emitter and collectors. So study the definitions for emitter, base, collector and their functions. Then note the difference between NPN and PNP transistor, I mean the circuit symbol. Then study about the full wave bridge rectifiers. Okay, now in the next class we will learn about the working of NPN and PNP transistors. Now for today this is enough. Okay, thank you.